Okay, because of some things we know about triangles, we can come up with this thing. We have some special right triangles. And the reason this is called a 30, 60, 90 triangle because that is the degrees of the angles. Here's your 90-degree angle, here's your 30-degree angle, there's your 60-degree angle. Okay, and just like with the Pythagorean Theorem, where we have like small ones that go up to get bigger, this is like the base triangle there. And here is where we come up with the numbers. Okay, well, maybe I should do this one first. No, let's do this one. If I took two of these triangles, I'm gonna draw it up like this. Can I do this? This is 30 degrees, this is 60 degrees, right? If I took this same exact triangle and flipped it around and made it, what do we call that transformation when we do the image of it? If I reflect it and I get an identical triangle like this, what type of triangle do I have?
Equilateral triangle.
Thank you, Cardinal Westfall. And what do we know about an equilateral triangle? Why is it called equilateral?
All sides are equal.
Because all sides are equal. So, if I say, just for whatever's sake, that this is 2, every side has to be 2, right? Okay, which is, see, the long hypotenuse side is actually 2 on my special one up there. Well, if I take half of that 2 away, and I only use this part right here, what is this distance from here to here?
1.
So there's my 1. Now, how do I find my square root of 3? Well, that one I have to actually use the Pythagorean Theorem. If I do a squared plus b squared equals c squared, it's not a perfect triple up there, but if I put my numbers in, here is 1 squared. Have we done this? I don't know what my b squared is, but I know my c squared, 2 squared is 4, right? 1 squared is 1. If I move my 1 over there by subtracting it over, I get b squared to equal 3. If b squared equals 3, what does b equal?
4. Square root of 4.
Square root of 3. Now, it doesn't matter if you understand how this all comes about. What you have to understand is this. This is the square root of 3 right here. Square root of 3. That this is your base triangle. Okay, it is the small triangle. If I told you this, we're only looking at this 30, 60, 90 triangle. If I have a big 30, 60, 90 triangle, I know this is 30, I know this is 60, I know this is 90 degrees. And I told you that this side was 5. You can tell me the lengths of all the other sides of the triangle because they are proportional to this thing. Which means this. Look at it. You have to know the 3 sides. This is the hypotenuse, right? This is the short side. This is the long side, right? If you look at the short side here, how does it relate to the hypotenuse? 1 and 2, how are they related? What do you do to 1 to get 2?
Add 1.
Double it. We're not adding. We're doing proportion, so it has to be multiplication. Okay? So that means if I double 5, that has to be the length of my hypotenuse. Okay? It has to be the length of my hypotenuse. What is this length going to be? Well, what do I do with 1 to get this side? Multiply it by
The square root of 3.
the square root of 3. So I have to take 5, multiply it by the square root of 3, which is?
Square root of 15.
No, 5 times the square root of 3. Okay, you can't put those together there. You have to just leave it. It's like an x. If you multiply 5 times x, you get 5x. 5 times the square root of 3 is not 15. 5 times a normal 3 is 15. Okay, so no matter what your 30, 60, 90 triangle is, you just need to know that the hypotenuse is twice the short side, and the long side is the square root of 3 times 5. Now hopefully this is not just some weird, strange number to you. you should be able to tell me kind of close, what is 5 times the square root of 3? I mean, in real, if I gave you 5 times the square root of $3, you should be able to tell me about what that would be. Anybody know what the square root of 3 is?
1 1/2.
Well, don't just guess. It's not 1.5. Otherwise, we just put 1.5 there. It is an irrational number, which means it goes on forever. It's a decimal, but you should be able to get close to the decimal here. Let me show you here. Here's my more tools. The square root of 3, square rooted. Write this down on your paper. It is about 1.73. The square root of 3 is approximately 1.73. Carter Westfall was guessing 1/2. It's a little bigger than 1/2 because 1/2 is 1.5. So in your head, Tyler, I'll bet you could come. What is 5 times 1.73? In your head, no. What's 5 times 17? You should be able to tell me. Oh, 8.5, is it not? 5 times 7 is 35. 5 times 1 is 5. 5 35.
8.5.
8.5 or so. 8.5. Okay. Let me give you another one. Let's say you've got a 30, 60, 90 triangle. Let's make it a big one. By the way, this only works for 30, 60, 90 triangles. You can't do this relationship that we're doing right now. If I know that this is 40 inches, you can tell me all the other sides because of their relationship. What do we know about the hypotenuse and the short side? Brant?
It has to be double
Right, so what number doubled gives you 40?
20.
Right, this has to be 20. Because the hypotenuse is 2 times the short side. And then this one's the goofy one because it deals with the square root of 3, but what is it? You should already know because I told you in the last one.
Wow.
You just take the short side and stick a square root of 3 after it. It is 20 square roots of 3. And because I said the square root of 3 is about 1.7, if you were asked to give that to be close, you would say it is, what's 20 times 1.7?
34.6.
Yeah, about 34. Which makes sense because you know that side has to be shorter than the hypotenuse because the hypotenuse is always longer. Okay? And that's why it's a special triangle because of those relationships with each other. Once you know one side, you know the other. One more. Let's see how good you really are. Let's do this. Boom, boom. That was my best work on this. But this is my 60-degree side. This is my 30-degree side. And this is my 90-degree side. And I say that this is 8 square roots of 3. What are the other 2 sides? What would the other 2 sides be? No calculating involved. You just look at it and go. One of them would be what, Brant?
The long one would be 16.
The long one would be 16. How do you know that, Brant?
Because the top one would be 8, and then
Because whatever's in front of the square root of 3 is whatever the short side is, and the long side, the hypotenuse, was twice the short side. Okay? That is the relationship of that. Now, back to the other special right triangle. The other special right triangle is a 45, 45, 90 triangle. Let's just do that. I'll redraw that. Okay. What do you know about 45, 45, 90 triangle? What type of triangle is this? This is an isosceles triangle. The 2 sides opposite the 45-degree angles are equal. So we're just going to pick them to be 1. And then because of the Pythagorean Theorem, a squared plus b squared equals c squared. My a's and b's are both 1. What is 1 squared plus another 1 squared?
1.
And that equals c squared. 1 times 1 is 1, plus 1 times 1 is 1. 2 equals c squared. So c equals the square root of 2. And those are your relationships if you have a 45, 45, 90 triangle. By the way, what is the square? Let's talk about this. The square root of 2 is close to what? Let's go back to my calculator. Where's it at? 2 square root. If I gave you the square root of $2, I give you $1.41. 1.41. So this you could always this is approximately that. So here, let me do another 45, 45, 90 triangle. Let's say I've got, well, let's not draw it to scale. Again, this has to be a 45. They have to tell you it's a 45, 45, 90 triangle. If this was 8, what are my other two dimensions of that triangle? Actually, what's the hypotenuse going to be? Oh, Tyler, why did you? What is the hypotenuse going to be? Who knows? Wait.
16 squared.
No, we already talked about this. For the same reason it wasn't 15 square root of 15 for the other one. Tyler, it's
128 squared. Square root of 128.
no. What are you talking about?
You did 6 squared.
What in the world is going on? Why, I think we're way overthinking this. Brant says
8 to the 8 times 2 to the square.
8 square roots of 2. Yeah. This is whatever this number is goes in front of this number. It's 8 square roots of 2. When it was 1, it was 1 square root of 2, so this is 8 times bigger, so it's 8 of those. And this side will be 8. It's the same thing. Okay, and again, 8 times the square root of 2, you should be able to tell me is close to what?
1.4.
What is 1.4 times 8? It's about 11. You can do the math, but I'll just tell you that's what it is. Another one. Here's a 45, 45, 90 triangle. Here's my 90. Here's my two 45s. What if this was 42 square roots of 2? How long would the other two sides be? It scares me when nobody else raises their hand here but Brad. Notice in front of the square root of 2 was a number. Notice that's the same number here. This one we don't put a 1 in front, but that's what it is. It's the same number here. Using that same philosophy, then the other two sides are going to be Carter Altenbert.
The same.
I need a number. Let me go back and explain this again. Notice the hypotenuse, 8 square roots of 2. Notice how this is the same number except it doesn't have the square root of 2. Nor does that have the square root of 2. This one is the triangle's turned, by the way. The hypotenuse in this one is 42 square roots of 2. What will these two be?
Square root of 2.
I'll give you one more shot at it here, sir. Here, let me spin here. Let me do this. Maybe this will help. My triangle on that other page is drawn upside down like this. Okay? This is 8 square roots of 2. The other two sides were just the number in front of the square root of 2. So if that's the same case for this, and this is 42 square roots of 2, the other two sides should be, there you go.
Yay! There you go.
Sometimes we just make it more complicated. No, I understand, because it's about, this is not the easiest stuff in the world. That's why it falls halfway through your 7th grade book. Okay? If it is a 45, 45, 90, you have two equal sides, and then the hypotenuse is whatever those sides are with the square root of 2 tacked on the front of it. Here's another one. How about this one? So here's my right angle. Here's my two 45s. Let's say this is 7. What would my other two sides be, Carter Westfall?
7 and 7 to the square root of 2.
And just that easy. Now, going back to this one, what if it is a 30, 60, 90 triangle? 30, 60, 90. And this side here is, I don't know, 18. What are the other two sides? I think I have that right, don't I? Yes, I do. Abram,
9 for the short side,
And
and then 9 times 3 to
just square root of 3. Yes, that is it. Okay, got that? If it's a 30, 60, 90, the relationships between the sides are like this. If it's a 45, 45, 90, then it's like that. You children are now wiser than most people even in high school.